All right, in this lesson, we're going to examine a class of graphs called bar graphs. Now, I note that the unit includes histograms in this unit. A histogram technically is not a bar graph. They kind of identify it as a special type of bar graph. They look similar, but a histogram is most definitely not a bar graph. A bar graph is for categorical data. That is things like brown, yellow, blue colors, months of the year, things that have categories but are not necessarily numerical data. Whereas a histogram is only for numerical data, like age, year, scores on a test, etc. If you want to create a bar type graph of numerical data, you often create a histogram. So let's get into it a little bit here. So a bar graph is something that you're familiar with, hopefully. Let's say we did a survey, and our survey included favorite colors. Okay, and on the survey they had these choices. They could pick blue, red, green, yellow, pink. I don't know. We'll go with that. All right. And let's say of those surveyed, 17 liked blue, 12 liked red, 11 liked green, 4 liked yellow, and 8 liked pink. Okay. In this case, we would set up a graph in which the height of the graph, the y-axis, would be the frequency. This is the frequency. That is how many times something was chosen. And the x-axis would not be a numerical at all for a bar graph. It would be categorical. And so we would put along the bottom our colors: blue, red, green, yellow, pink. Okay, and I want to point out a couple of things about the y-axis. You might be tempted to think, well, the smallest number is 4, so I'm going to start at 4, and I'm going to go up to 17, right, from starting at 4. What that does is that distorts the graph. That makes it seem like there are greater differences between the columns than is actual. So it is a good idea, if you want to create a graph that's non-distorting and is not misleading, to start your scale at 0. Okay. What's more is we have to decide what to count by. Our count by number needs to be an even number. That is a consistent number. Okay. So I need to cover 17. If I count by 2s, let's see how far we get. 2, 4, 6, 8, 10, 12, 14, 16. Yeah, that'll work. That'll work. If I tried to count by 1s, I would run out of room pretty quick. A straight edge is an indispensable tool for a bar graph. So let's make sure to use a straight edge. Okay. And here we go. All right. And then the next task is to make our bars. So, and I'm just going to mark the center of each of these. Okay, and now notice they're not evenly spaced, but that's not terribly important. Blue is 17, so that's halfway here. Red is 12. Green is 11, halfway between 10 and 12. Yellow is 4, and pink is 8. Okay, and then we make our bars. So I'm going to make each bar 2 spaces wide. Oops. Okay. Now, in reality, most of the time we don't use pencil and paper, but we use technology. what I'm going to bring up here in a moment is Microsoft Excel. However, any spreadsheet is capable of doing this, even Google Sheets, though the buttons you press or the menu items you select are okay. Here we go. Right. Okay. All right. One of the key factors here to distinguish between a bar graph and a histogram is in a bar graph there are spaces between the bars. Okay. In a histogram there are no spaces between the bars unless one of the bins is empty. And we'll get to that point in a little bit here. All right, there we go. All right. So there's our completed bar graph, and you might choose to label it, favorite colors. Okay, let's jump over to Microsoft Excel. Okay, and then play with that here. And let's see what we can do with Microsoft Excel. I'm going to open a blank workbook. Okay. And let's change the view to 200% zoom so you can clearly read. Okay, and the first step when using technology is to make a table. So I might have a label, favorite colors, and color, blue, red, green, yellow, pink. Okay, and have our numbers here, 17, 12, 11, 4, and 8. Okay, whoops. That's because I started in the wrong place. Cool thing is I can select and grab the border and just drag it down. Frequency. Now you can, if you're familiar with your programs, shortcuts here, you can do things like home and merge and center. You can make a table. You can auto size the thing here, and then we can add a border, thick outside border, bottom line, bottom border, and we can all borders. There we go. Okay, whoops. That overwrote the thick outside border. So redo that. Okay, there we go, and you can play with that. But then another thing I like to do is insert blank rows and columns. Okay. But when it comes to making a bar graph, it's really as simple as this. Your spreadsheet allows you to, in Microsoft Excel, we choose the insert. We select the table, actually select the table with the column headers, right? And the items here. And then we select insert, and then you have all these bar graph types here. Select bar. Well, here's a bar graph here. Column or bar chart. That's different than statistics chart. That's where you get your histogram, I believe. Okay, and there are various types. We can use 2D columns, and it gives you a preview. We can use stacked columns. That's when you have more than one category, and we'll look at that here. And then percentages. 3D columns are kind of cool. Be aware that you don't want to select the graph type that distorts. Okay, because the horizontal 2D bar and so forth. I'm going to choose a standard here. Okay, and notice it labels this frequency, so that's not what we want here. But it labeled all of the items here. Okay, but let's change the title. Favorite color. Okay, And you can do things like right click on the bar and add data labels, and it can tell you exactly how much is in each. That's kind of useful. And there are some other things you can do as well. Now, one interesting thing, let me undo this here. Let's say I was doing a comparison between kindergartners and seniors in high school. Is there a difference in the colors people like when they're seniors? Okay, and let's say seniors 12 liked blue, red, 15 green, 18 yellow, 2 and pink 1. Okay. And now we can make a double bar graph here. Double bar graph. So I'm going to insert bar graph. And here we go. So notice now it creates what we call a key at the bottom. Blue is kindergarten. Favorite colors. And now we can side by side compare. More seniors like kindergartners liked blue than the seniors did, and so forth and so on. So side by sides are really nice when you have more than one set of data. But a reminder, bar graphs are for categorical data. That is colors and things that generally are not numbers, not numerical type data. Now if I want to keep track of numerical type data, we create what's called a histogram, and we create what's called a frequency table. Okay, so let's say we had a test, okay, and we have the following test scores. Okay, and let's say there were I'm going to go, well, yeah, I'll do it by hand first. Test scores. So we had a 98, 87, 88, 91, 54, 62, 73, 84, 82, 71, 63, 90, 85, 78, 70, 65. Okay, let's say these were our test scores for a given test. Okay. We might be tempted to create a bar graph, but really what we want to do is create a histogram. And to create a histogram, we create something called a frequency table. Okay, and for the frequency table, I take note of what the largest and the smallest numbers are. The largest number seems to be 98. The smallest number, I think, is 52. So 50s. Okay. Let's see, 50, actually that's going to work pretty well to do this. So 50, 60, 70, 80, 90, okay? And these are called bins. Now, it's 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. But there's a rule. Notice that 60 is in both, right? If a number is in both, it always rounds up. It always goes to the next highest bin. So 60 would actually go in the 60 to 70 bin, not the 50 to 60 bin. Now I do this because that is technically the proper way to divide the bins. The boundaries actually are the same. And any number that's on the boundary goes to the next highest bin. That's the technical way to do it, because not all numerical numbers are whole numbers. Yes, we could have written 50 to 59, 60 to 69, 70 to 79, okay? But the convention is that the boundaries are the same, okay? And again, we keep track of frequency, okay? So 98 goes in the 90 bin. 87, 88, 91, 54, 62, 73, 84, 82. Whoops. I'm writing numbers instead of tick marks. Must still be early in the morning, 1 tick mark each. $71, 63, 90, we're just tabulating. 85, 78, 70, 65. Okay, so there's 1, 3, 4, 6, 2. Okay, and now when we make our frequency, our histogram, here's the way it works. We have our x and y axis. The frequencies go up the y-axis. Okay, and the scores go across on the x-axis. Okay, so again, now we have a count by to figure out for both, all right? So the highest frequency is 6. So I'm going to go 0, 1, 2, 3, 4, 5. Something I can do with my computer that you can't do on paper very well. Come on, I want to move you. There you go. And 6. Okay, and our x-axis goes from 50 to 100. Now in this case, you could start at 0, but it's really not necessary to do so, because what we're worried about distorting is the scale on the y-axis, not necessarily the x-axis. So, and the way we do that, by the way, is we insert this little zigzag in to indicate that we are skipping. So I'm going to go 50, 60, 70, 80, 90, 100. Okay. A little zigzag indicates that we're skipping something. Okay, here we go. Voila. Voila. Okay. And let's now insert our bars. So 50 to 60 is 1. 60 to 70 is 3. 70 to 80 is 4. 80 to 90 is 6. And 90 to 100 is 2. Okay. Straight edge. And note now we don't put any space between the bars at all. Okay. No space between the bars. No space between the bars. No space between the bars. Okay, and this is called a histogram. Now if I turn the height of each bar into a percentage, then what we essentially have is what's known as a probability curve, where the area under the entire curve is 100%. And I would do that by dividing each frequency by the total number of test scores, to turn it into a percentage. Which is something we're going to get into for probability distribution later in this course. Okay, histogram. All right, let's explore the histogram in Excel here. Let's see how this is done. Did I close Excel? No. Okay. Get rid of everything. Delete, delete, delete. All right, there we go. Okay. All right, so let's try some test scores. Okay, 98, 87, whoops, nunlock. 98, 87, 88, 91, 54, 62, 73, 84, 82, 71, 63, 90, 85, 78, 70, and 65. Okay. And let's grab this and insert. Okay, and choose Insert Statistics Chart. Okay, so we have histogram, and histogram with a cumulative frequency as well. There are more statistical charts down here. There are box and whisker plots. These are the vertical kind. Okay, but I'm going to choose this here. Now I want to see, is there a way, it made 3 bins, right? It made 3 bins from 54 to 71, 71 to 88, 88 to 105. I'm interested in changing the number of bins. Format, select. Okay, I'm going to pause the video and do a little read. All right, I found it. Okay, so to modify the bin width, in the recent versions of Excel, you right-click on the data series and choose Format Data Series. But it's not here because I'm using Office 360. Okay. However, in Office 360, you right-click on the X-axis series and choose Format X-axis, and then there's an option called Bin Width. Now the bin width is 17. I'm going to make the bin width 10. And there we go. All right, so 10, notice it's going 54 to 64. Okay, not sure, overflow bin 115. They're not giving me the option to choose. Okay, automatic, number of bins. I can choose the number of bins if I want 7 bins. Okay. And notice the numbers get really kind of wonky when you do that. But notice something else. When I increase the number of bins, the shape of the graph changes. Right? 10 bins. What if I do 20 bins? Right? Now we actually start getting some spaces between the bins. A good rule of thumb is you want between 5 and 10 bins. So between 5 and 10 bins. I'm just going to set the bin width to 5. Okay, and that makes 9 bins. That's a decent graph, and so on. Right? Now there is also the cumulative frequency table, or cumulative frequency option here. And let me show you real quick what that means. In this table here, cumulative frequency is adding the bin to the next bin here. So one person scored in the 50 to 60, so cumulative frequency is 1. Okay, the next bin, 60 to 70, scored 3, but I'm going to add the 3 to the 1, and the cumulative frequency is 4. Add the 4 for the next bin to the 4 previous, and we have 8 that scored in 80 or less. Add the 6, we have 14. Add the 2, we have 16. Okay, and so now you can see the numbers growing this way here. Okay, and let me show you what that looks like in here. Okay, so test scores. Okay, insert, boom. Okay, insert, and this is our cumulative frequency. Again, I want to modify the bin widths. Format axis. Bin width is 17. Let's set it to 5 or 4, 5. Okay. All right, and you can see what happens to the frequency as it goes. Now, interesting. It's not scaling the axis correctly. What happens if I data sort? sort the values in increasing order. Doesn't seem to change it. That's a curious thing here. Now these are in order, but these are scrambled. It seems to do most popular, and that's a problem here. I'll have to figure out why that is. Okay. But so you can see some of the problems that we run into with technology. Okay. In this particular scale, now if I change the scale here, because I'm not going to fit 16 in here. So let's do 2, 4, 6, 8, 10, 12, 14, 16. Okay, the first one is 1. 50 to 60 is 1. Then 4. Then 8. Then 14. Then 16. Okay. And so the cumulative frequency graph is always going up. The least it can do if one of the bins was 0 is stay flat. Never comes back down. Okay, that's the nature of a cumulative frequency table. All right. So hopefully this helps as you explore bar graphs and histograms and frequency tables and cumulative frequency tables. Okay. Let me know if you need help.